So for our second keynote on the anthropological implications of artificial intelligence, we have Professor Sara Lumbreras, who is Professor of the ICAI School of Engineering of the Universidad Pontificia Comillas, which I'm sure I've pronounced horribly.
That was quite good, actually. That was quite good. I'm surprised.
Thank you. She's currently the Deputy Director of Research Results at the Technical Research Institute and manages the chair of Science, Technology and Religion together with Jamie Tato. She's the author of more than 50 academic publications and has directed or participated in more than 20 projects in private companies and public institutions. And her research focuses on the development and application of decision support techniques to complex problems, which I'm sure is less complex than it sounds. She works with classical optimization techniques such as Bender's decomposition, heuristics, and artificial intelligence, and operates in the energy sector, health sector, and in finance. And then on top of all of this, she also works and develops a lot of research in philosophy of technology and the implications of artificial intelligence in anthropology, which is what she's going to be discussing today. And she's also a global shaper of the World Economic Forum and a Marshall Memorial Fellow. So Sara, thank you so much for joining us, and I will hand over to you now.
Thank you so much, Finley. It's a pleasure to share this conference with you. And yeah, so what I'm gonna talk about today are these implications of artificial intelligence and what it means to be human. And before we start, it's necessary for us to take just a moment and realize how unprecedented the technological developments are being during the past few years. Just to give a very brief illustration, I'm sure that most of you will be familiar with the pictures that I have at the right-hand side of this first slide. The top one is a work of art which was given the title Space Opera, and that succeeded in winning the Colorado Digital Art Fair a couple of years ago. And there was a lot of controversy, as I'm sure that many of you recall, because only after the judges made public their verdict that this was the winner, then the author said that actually it had been created using DALL-E, the generative artificial intelligence. And there was quite a big fight in Twitter, now X, with people saying that the artist should actually withdraw from the competition, and that this was not a fair entry for the contest. However, the judges, after examining the case and seeing what the process had been of creating this painting, by the way, it was made public, and there were like over 160 different drafts, and for each of the 160, a very long list of prompts where everything was refined and make a little bit better. So the decision was that artificial intelligence had been used as a different tool, as something that was akin to using a brush. And this was quite unexpected, because, as I said, this was digital art, and digital art meant until that moment that it was just using manual work and some software maybe to modify the images or things like that. And it has been understood since then that generative artificial intelligence in particular is like a new type of brush, a new type of tool that can only be used as a tool for human creativity. Something that expands, but in no way can be understood as the creator. The second image is from a software that detects skin cancer. So I don't know if you missed that paper, but in 2023, there was a paper on Lancet, a top medical journal, that said that actually in image diagnostics, artificial intelligence was now considered to be better than human beings for all the problems that it had been seriously tested for. In the case of the skin cancer, it's not only that we can find that the performance is superior, but it has also made it much, much cheaper to analyze and diagnose. This is going to be a revolution in diagnostic, which is going to bring the cost down. By the way, this doesn't mean that we can substitute the human doctor for diagnostic. Diagnostic is a very complex problem. I'm just talking about image-based. So when we analyze an image for a tumor, for instance, the machine is the same or better than the human being. It's completely different when we have to take into account all the history and all the nuances. And by the way, in the latest job report from the World Economic Forum, one of the professions that was anticipated to be the first ones to disappear is that of osteometrist. So the people who tell you if you have osteoporosis or not, which is quite of a simple measurement, this will be, of course, substituted by the machine. And the third image is, of course, Neuralink from Elon Musk. And this is, as you know, it consists on implanting a chip with sensors that, by the way, this is technologically quite impressive because they are so thin, much thinner than a human hair, and they can read the electrical fields in individual neurons. And we can read tens of thousands of individual neurons. Only with that information, we wouldn't be able to do anything because it would be very noisy. We don't know precisely what is going on there. What we do know is that the information is coded there some way, right? The idea of Neuralink, by the way, is that it is implanted in the motor cortex. And I don't know if you are aware that the signals in the motor cortex are similar when you move or when you imagine that you are moving, only that the intensity is a little bit lower. And they also appear when you are watching someone move. So the three things kind of provoke the same activation. And even though this information is very complex and very noisy, and some years ago we would have said that it was impossible to read what that meant, artificial intelligence means that we can train systems to interpret the individual positions of the neurons and get a result that might be something like moving the left leg or putting your arm up or things like that, this sort of information. And this is why the anticipated use of this technology is to give back mobility to the people who are right now disabled. This doesn't mean, by the way, that everyone who wants to use Neuralink is disabled in some way or another. Just out of curiosity, there were thousands of people who were volunteers for testing. The tests have happened this year, and most of them were not indeed disabled. The desires that they had more to do with being connected to the internet or being able to turn the lights on and off with their minds and things like that. It's quite surprising, but you would be surprised of how many people actually have had already implants just to have their keys or the transport card, things like that. So now we found ourselves in a situation where technology is redefining what is possible and what is not, and AI is one of the main agents there. We could also talk about the fourth industrial revolution, and you know how the main component there is that we used to have different technologies of the biological, technologies of the information, technologies of the culture. And in the fourth industrial revolution, everything is coming together. And with AI, again, having a big role there, and making also possible to use technology on the human being, which is the meaning of anthropotechnics. And this is something of which Neuralink is such a great example. So it's through technology and AI that these things can happen. By the way, another thing that is quite interesting that I haven't mentioned is that implanting these sensors in the brain is quite risky, because if you touch one of the tiny blood vessels, obviously the person will have a stroke and bleeding in the brain, and this is not acceptable. So the only solution has been to develop another AI system where the tiny movements of the person, even if you have your head made immobile, you still breathe and your heart still beats. So there are tiny movements that are anticipated by this artificial intelligence, so that the robot that puts the sensor in can avoid these tiny blood vessels. Quite impressive. So we are now in this very rapidly changing situation, and we really need to reflect on what everything means and how we can apply all this technology for the good. And as Pope Francis was saying, to avoid being in a world where we are very rich in technology but very poor in humanity. If we take good decisions now, we could hopefully be rich in both ways, right? And anthropology, I would like to stress that anthropology is the key to ethics, and in particular in the ethics of technology. Why? Because we could define humanizing technology as technology that makes us more human, that makes us more how we want to be. And bad uses would be the other way around. We can only know what helps us be human if we know precisely what being human means. And as I will explain now, there are quite a few ideas that underlie the developments in AI that are quite wrong with respect to what we know about human beings. And the key points that I would like to touch upon are the question of authenticity, what is the role of the body, and I would like to finish by talking about artificial intelligence in the context of the Imago Dei, what it means that we are children of God. So coming towards authenticity, I guess that you are also familiar with the picture in this slide. It's Sophia given citizenship in a PR campaign, in an advertising campaign, but nevertheless having been made a citizen. And I think that it's very important to basically understand what AI is and what it really can and cannot do, because a lot of the confusion is coming from not having worked with the tools themselves, and even in some of the philosophical debates. So in a very, very simple way, simple and a little bit simplistic, but very clear and working concepts, AI can be understood as pattern recognition. So if we are all familiar with what a linear regression is, we find the relationship between one dependent variable and a set of independent variables, and we express this relationship as a linear function. In artificial intelligence, what we have done is that we have generalized this. So we can find any type of relationship. Very often we talk about neural networks. Neural networks, they are what we call universal approximators. This means that even if the relationship is very, very complicated, when with enough data and with enough neurons, we can learn the pattern that is there. And we can make this learning in two different ways, which are expressed in the right part of the slide. We can have data that or learning that is not supervised, and this means that we are going to find patterns in the data without telling the machine what it needs to discover. So in this example, I can send different images of animals, and the machine could find a pattern and see that there are some animals that looks like a dog and some other animals that look like a cat, and it's going to sort them. And this can be quite easy to do. And also I can train the machine to predict a specific bit of information that I find most interesting. In the example with the cats and dogs, how it would work is that I am going to give a long list of animals, and for each of them I will give a label. And I'm sure that you've heard about these problems with people in underdeveloped countries being paid very, very little to just give the labels to the images. So they are going to have a label, and the machine is going to learn what is the underlying pattern in the examples that makes a cat being a cat and a dog being a dog, so that the next time that I present an image, the machine is going to be able to identify it as one or the other. So this is basically what artificial intelligence is doing, is recognizing a pattern and applying it to the next data point that you introduce. And there's also another element that is really, really important, which is that evolutionary algorithms, they optimize the function that the programmer gives it. So, and in there, I have put an illustration of evolution, of Darwinian evolution. And in the same way, an algorithm that we train, because training works, and the reason why it works is the same reason why evolution tends to progress in terms of fitness. For the same reason, the algorithm will end up learning the data. And for many of the types of the algorithms we use, we actually do have mathematical proof that this evolution happens, and that the learning, provided that the data are there and that the algorithm has been well built, those patterns will be found. But it does nothing more than this. So every goal is established by the programmer. The machine does not establish goals. The machine does not understand. The machine does not do any more than this. And something that is relatively new is that usually when we worked with this type of tools, we were only looking at things that could be expressed as numbers. So language was left a little bit out of this equation. And since a few years ago, we worked really well with language as a numerical object. And I wanted to show you just an example so that you can imagine how we can do this. There are here like several words. So you have dog, puppy, cat, houses, things like this. And we have created what we call mathematically embeddings. An embedding is moving from one space, this is the space of the words, and we move to a space where we have series of numbers, arrays of numbers. So in this case, you can see that if we represent these numbers graphically, you can see that houses is very far away from puppy, but puppy and dog are very close, and puppy and cat are much closer than puppy and houses, okay? And in the same way, we can see that the relationship between man and woman is the same as king and queen. This is what we call word embeddings. And in the past, let's say 5-7 years, are the underpinning of what we have now, which is large language models creating all this revolution. But the important thing is that all the algorithms that we have, they work with numerical data, and right now we can transform language into numbers as well. But we need to keep in mind that this transformation is not an equivalence, because there's much more to the concept of puppy than this string of numbers, right? And what is it that cannot be represented? There is a lot of context that is going to stay away. As I was saying, there is much more in the concept of puppy than in the series of numbers, but there is one difference that is particularly important, which is that there is no subjective experience in the machine, and there's nothing to link the data that the algorithm is processing to reality. And let me explain this a little bit more, because this is a very, very important point. So in this illustration, I have brought to you the example of an app, a mobile app, that identifies colors. So this is an app by Pantone. So actually you show your mobile phone a color, and it can identify what color it is. So it will be able to tell you if it is blue, if it is red, and what kind of red and blue. However, obviously, there is no experience of red or blue in the machine. At most, in the machine, there will be a representation, a very crude representation, probably with just 3 values, like RGB, red, green, and blue, of what the color, or how the color can be represented in these 3 dimensions, but there is no experience of color. And there is nothing that can tell us that those 3 values, if we saw them in isolation, nothing connects these 3 values to the reality of color. In the same way, when we look at the ones and zeros inside the machine, there is nothing there except for our interpretation. An interpreter needs to be there. There is nothing that links them to the reality of color, to the reality of temperature, if this is a temperature sensor. There is nothing there. This is what we call the symbol grounding problem. It's not evident at all how to give meaning to the symbols, if not by a conscious being consciously interpreting this symbol. And of course, there is no intentionality. The purpose of the problem and the objective of the problem needs to be given by the programmer. There is no auto fixing goals. And the bad thing here is that even though now that I'm saying this, I would hope that this seems quite obvious, this is not the case at the front that is developing the technology. So for most of the people developing and working with these algorithms, this problem is kind of forgotten, that there is no subject experiencing and no subject understanding. No one understands because the algorithm does not have any subjective experience. So who needs to understand? The human being using the algorithm. This should be obvious, but it is forgotten. And there is one very important problem when we use algorithms that we call black box algorithms. So neural networks, the most well-known one, the celebrity algorithm. They are really good because they can approximate everything. And as I said, they are universal approximators. It's very easy to stack them together and to make very big models. However, once the model is built, it will give us if the animal is a cat or a dog, so to speak, but it will not tell us why. It will not explain what are the reasons because it's a black box. And if we just trust the algorithm to make a decision because statistically it tends to get it right, then we can create really, really worrying issues. And this takes me to the last image that I have here, which I guess some of you will be familiar with. This comes from an investigation from a journal called ProPublica in the States that investigated a software. The name of the software was Compass, and it was used to try to analyze if a convict had a high risk or low risk of recidivism. So if the convict was deemed to have a high risk of committing a crime again, then they would deny the possibility of giving them a parole. And if the risk was low, then chances are that they would grant him parole. So in this case, as you can see, we have the example of this. This is real. This is this James Rivelli. This guy was deemed low risk with prior offenses that looked like one account of domestic violence, aggravated assault, which is not with your hands, but with some type of weapon, one grand theft, one petty theft, one drug trafficking. He was considered to be low risk and was granted parole, and then he committed again one grand theft. And this Robert Cannon was considered to be higher risk, so medium risk in comparison, and he only had one petty theft. Okay, so he was not given parole, and then when he came out of prison during all the years that the study took place, he never committed a crime again. In the investigation, it was later made clear that there was a huge bias against African Americans. And this is something that comes up time and again. If the data are biased, then our AI system will learn the biases in the data. And we've seen this. We've seen not very long ago, there was a large tech company that said that they were not using AI anymore to sort the CVs because they were automatically disqualifying all females from their applications, because the algorithms had learned that traditionally all the guys were hired, or better said, that all the hires were men. So every time that there was a woman, they would automatically be disqualified. So they were not using this system anymore. I don't know if I believe that they were not using it anymore, but the point is that we incur biases. Or there was a social network, and this is quite bad as well, that was discriminating against non-white women, because non-white women had a much higher chance of having their images labeled as inappropriate content. How can that be? Well, in order to train the algorithms, we need databases. We need these examples. You need cats and dogs, right? So in this case, you need a database for proper images and a database of inappropriate images. The proper images, they took them just from the internet, from advertising. And apparently in advertising, there is overrepresentation of white women, and in particular, blonde blue eyes is overrepresented. And for the inappropriate images, they went to Pornhub, to a pornographic site. And apparently there is a lot more racial diversity in pornography than there is in advertising. So the algorithm learned that when there was someone who was not white, then chances are that it is an inappropriate image. Okay, so where does this problem come from? It comes from the fact that we are letting the algorithm decide. We are using black boxes, thinking that some way or another, the algorithm is understanding what it does. No, you need to understand what the algorithm does. And you need to use transparent algorithms. If you give me the reasons why this person is not granted parole and this one is, and you tell me that the reason why this man is not granted parole is because he's African American, then of course I'm going to say that this is not acceptable. So bias, and what we call algorithmic bias, is a consequence of not understanding that all the comprehension and all the responsibility of the decision needs to come from the human being. And this is very, very important. And there is also this myth that says that artificial intelligence algorithms need to be black box in order to be statistically good. And this is a belief that we need to challenge. So some people say that good algorithms don't tell you the reasons. This is the point. And it is not true. There's a lot of research on other algorithms, transparent algorithms, that leave us really understand what is going on. There's one researcher, her name is Cynthia Rudin, who replicated Compass's algorithm using transparent AI, what we call explainable or interpretable AI. They are like different levels. The top one is interpretable AI. And she was able to get predictions, forecasts of recidivism that were as good as Compass, using only information that actually makes sense from a criminology standpoint, which was age and the type of crime. So younger people, they have more chances committing the crime again, which makes sense. And also when a crime is violent crimes tend to be repeated more than non-violent ones. This is something that can help us decide, and that doesn't contradict fairness, is not including this bias. And as I was saying, those are algorithms that are maybe more recent. There's a lot of research, a lot of things that are being explored, but it can be done. And we need to make it something that we request as a society. It's good, by the way, that in the AI Act, there's some focus on transparency for the decisions that are considered high risk. So I really hope that we see these explainable algorithms being pushed and being developed more. What happens on top of this? We have, because what I was presenting until now was all matter of fact, all things that we have already here. But there is something that lingers in our atmosphere, in science fiction, in the beliefs of the Elon Musks of the world, which is the possibility of creating artificial consciousness. And we have many authors from the groups of transhumanism that really believe that very soon from now we will have artificial consciousness, that we will have, if we use Kurzweil's words, spiritual machines. And in this, for these people, both machines and humans would share their main nature. And this main nature that they assign to both humans and machines is that of being a pattern recognition system. So this idea of artificial consciousness assumes that human beings are only human brains, and human brains are only pattern recognition systems. And one thing that should be stressed is that there is no proof that existing technology can generate artificial consciousness. We don't even know very well what consciousness is. There are a lot of theories. We will delve a little bit more into this because it's very interesting. But what we can say with confidence is that there is no basis to think that this is possible, and there is no basis to think that human beings can be reduced to pattern recognition systems, or not even to their brains. This is against the science that we have. And the bad thing is that we are now living in a context that is ruled by functionalism, in the sense that when two things serve the same function, then they are considered equivalent. And this has led to many different issues, but with this one about artificial consciousness, we are facing a lot of confusion. I guess that many of you are familiar with this story at the left of the slide. The name of this guy is Blake Lemoine, and he used to be an engineer in Google. He worked training one model similar to ChatGPT, but it works on a different architecture that is called Lambda. And as part of the training, he was having conversations with the chatbot. And at some point during the conversations, this guy became convinced that Lambda was conscious and asked Google to protect it, to give it rights in a way or another. And when Google didn't like these suggestions, this guy talked to the press, and he started a campaign asking for human recognition for this AI system. He was, by the way, let go by Google, and what they said was that it was not because of the weird publicity. but it was because he had made public all the conversations that he had in training, which was something that he was not supposed to do, but it gave us the opportunity to read them and see what precisely was going on. So of course I went and read them, and it's quite interesting that how naive human beings can be. And let me give an example. So Blake was asking, so you being a machine, what is it that you fear the most? And then the machine would answer, yeah, me being a machine, what I fear the most is to be switched off. And this might sound correct, or like something that, were the machine conscious, this would make sense. However, we need to realize that it was trained with all the examples in the internet of all the science fiction stories where machines are afraid of being switched off. If we read a little bit more, then Blake would say, and what is it that you like to do? What do you like to do with your time? And the chatbot replies, because it finds the patterns in the data. So the thing that makes the most sense to say is, what I love to do the most is to spend time with my family and friends, which obviously doesn't make any sense. And right now, we are at a point where people are forgetting how we build these systems. And they are forgetting, as I was saying, that the symbols are not interpreted by anyone. There is no subjective experience. And the only thing that happens is that our machine learning algorithms work. So what we have done is that we have trained, basically with large language models, we have trained machines to be able to pass the Turing test. We have trained them to pass the Turing test. And when they have passed it, we've become surprised. This should not be a surprise at all. We know that the algorithms work. And here, I find that it really helps me to use this example of a cockatoo or a parrot. You know that parrots, they can imitate human speech really well. They can say words, they can even imitate a man or a woman's speech. It's easy for them. I could buy a parrot and train the parrot to tell me, I love you, Sara. I can do that. I don't know how many cookies I need to spend training the parrot, but in the end, I will do it. In the same way that I don't know how many artificial neurons and how many data points I need, but in the end, I will pass the Turing test. So the day that I come home and my parrot tells me, I love you, Sara, if I think that the parrot really loves me and I get, I don't know, a fuzzy feeling of oh, really my parrot loves me, then I'm an idiot. I have trained it to learn to say that. And the same thing has happened with artificial intelligence. And we are now finding more and more people that are worried about this artificial consciousness and thinking about general artificial intelligence. This is not what the machine is doing. The machine is finding the patterns that you ask it to find using algorithms, evolutionary algorithms that are proven to work, and nothing else. And the only surprising thing, if I may tell you, is that it was so easy, to be honest. Because if we think about how ChatGPT works, you know that ChatGPT has been built using, I'm gonna simplify this a lot, but the main ideas are what I'm going to express. So basically, ChatGPT works by finding what is the next most probable word. Okay, so it has all the patterns statistically in all the corpora that it has used in the training, which includes, according to what they say, but we can never be sure, 10% of the internet. So all the patterns in 10% of the internet of what are the pairs of words that are together with a higher probability, groups of 3, groups of 4, things like this. And what is surprising is that only with this and with a mechanism that is called attention, which means that we don't look at all the context, but just at the most significant one. Just with those things, we are able to pass the Turing test so well. The really interesting thing here is that it was actually easier than what we should have expected. Also, there have been a couple of moments that were very surprising. One of them was that in ChatGPT, they in the usual training, it seems like the machine developed a theory of mind. You know theory of mind, right? So we can put ourselves in the shoes of others. And the machine, just by understanding the patterns in language, is able to do that as well. Not perfectly, because again, there is no understanding. But mostly it can behave as if. Remember what I was saying at the beginning, that the question here of authenticity is the question of essence versus appearance. And the system really does appear as if it has a theory of mind. But it's because theory of mind is so embedded in our language that it was able to learn it just by looking at the relationships in the words. Also, another thing that is quite surprising is that now that we have AI, we are probably going to revolutionize our way to do science. And one of the things that I would like to see the most for the next decade is these methods that I will explain in a bit being developed and taken beyond. So basically, we are used to live in a world where the only thing that we have from data is correlation. We can know that, I don't know, obese people are more depressed. And this is correlation. But we don't know if obesity causes depression or if it's depression that causes obesity because people don't move as much. Or maybe it's the two ways. So up until very recently, we just needed to stay content with analyzing correlation. But right now, we are developing causal models. And with the help of AI, we are trying to develop a different kind of science that can tell us a little bit more. And very often, we can say things about causality. Not always, but very often, if we have enough data and the data allow, we are starting to do a little bit more than what we used to have with these causal models. And also, there is this realization that reality is much more than the data that we have, and that there are different levels of evidence and different levels to explanations. I really liked the speech by Mark earlier. So we used to think in terms that in the end reduced to the basic level of data, but right now I think that precisely because we can analyze that much data, we see very well what is missing, and things such as the personal explanation are missing, and there are people who are starting to build different types of science. Also, AI is changing the way in which we perceive beauty, and here I have aesthetics and AI, and we have the two directions. So on the one hand, in the same way that we have transformed words into numeric arrays, we are transforming faces into numeric arrays, and we are finding what is like their beauty rank in just one number. In the same way that we are trying to quantify health, we are trying to quantify anthropometrics, we are trying to reduce human beings to numbers and to scores. And this movement, which goes which starts with health, we can argue, which we call the quantified self, is also generating it's also generating a rejection, and it can also show us that we cannot be reduced to numbers. And another problem that we have is the one of the interpersonal relationships. I don't know if you are aware of what the first picture is. The first picture is called Xiao Eyes. It started being developed by Microsoft, but then it was bought by a Chinese company, and it provides an artificial girlfriend. So this is like an avatar of a Chinese schoolgirl, and it's a service where the user can get conversations that can be customized. It can send text messages or WhatsApp messages with the tone and with the content that the user prefers. If someone prefers his artificial girlfriend to say good morning, good night, and sing a song, then she would do that, and so on. And the interesting part is that this service has hundreds of thousands of users in China, and many of these users, what they say is that they find having a relationship with Xiao Eyes better than having a relationship with a real human being. This is quite astonishing, and also we need to take into account here that with AI, because it can learn anything, it can also learn our preferences, and it can learn to optimize our attention, as we've seen with the algorithms in Facebook, for instance. So this sort of developments, they can learn pretty well what are our preferences, whatever gets our attention, and mimic that to get basically there was one Spanish author that was that famously said that the most intense type of attention is love, and this is starting to happen. There was a study last year of a Chinese group. The first author is Yu, and with only 10 points taken from social media, they were able to anticipate a response to a test much better than the best friend of the person. So it's quite easy to get to know us and to manipulate us, because as I said, what we know about AI is that it does learn. And as I was saying, artificial company is a reality, and not only these Xiao Eyes, but they are also like several dozen companies that are providing artificial company for the elderly, for instance. So what is that telling us about what it means to be human? Is artificial company? No, it is not. There is no interiority in the machine. And these developments, even though they might seem like a good idea in the short term, they really devalue what human being means. Now, I would like to give a couple of points about what happens with the body, because as I said, to these developments, there is this underlying idea of patterned dualism. So there is the body on one hand and the mind is in the patterns in the neurons. So if this is true, then we can go to any other substrate. By the way, here you have the Blue Brain project, where they are trying to basically copy all the connections in a brain, scanning the connections individually. There is also the Blue Worm project, where they have and some years ago already, they managed to copy all the connections in a C. elegans worm, and you can simulate things and play with the model. It has less than 200 neurons, so it's quite small. So the ultimate goal would be to upload our consciousness, as in science fiction, and have an immortal life. There are several companies that are already marketing this, And just as a curiosity, because we have written some, I would say, interesting papers on this issue from the philosophical side, not very long ago, I had a visit from someone who was hired as marketing by a company that produces this, they call them thanatorobots, which means that someone's dead and you upload the consciousness. And there are some companies that are there already promising this. And what they were saying is that they found that marketing this was a bit challenging because you are selling hope. Of course, there is no basis to think that this is true. And what science tells us is that actually our mind is not only in the brain. There was a few years ago one very interesting paper from Sarah Lane Ritchie that was titled, maybe Mark was a co-author. Now that I think of it, I'm not completely sure. That was called "Let's Get Our Mind Out of Our Brains," because science is telling us time and again that, for instance, the gut-brain axis, what happens in the gut and the microbiome in the gut, has a huge impact on our mental health. So this is not true that our identity is in the brain. We are embodied in the most intense sense of the word. And I just wanted to bring here as a note on the topic of consciousness that there are many theories of consciousness right now. None of them is satisfactory or totally satisfactory. Here in this one, I took this from one of the papers from Tononi, from information integration theory, which basically means that consciousness just means to have more information together at the same time, which can be interesting. However, the mathematical developments have been shown to be poor. So it's arbitrary the way that this integration is represented. And it also leads to panpsychism, because in everything there will be information that is a little bit integrated or more integrated. And also we have the 4E cognition model of consciousness, where we have that in order to have consciousness, we need to have embodiment. So whatever system that we create needs to be in the world. It's going to be embedded in the sense that it is within a context. So it's not just the system, but the system as a context, as we would recognize from so many philosophers, and phenomenology being one stream that was very clear on this. It's going to be extended because it's not only what is in the system, but also outside, and it's enacted because it can act on its system. However, I just want you to realize that any way that we can think of to enhance current technology, to enhance a computer so that it is embodied, we think of using sensors. And to enhance a computer so that it is enacted, we use actuators, an engine, a robotic hand, whatever. However, we never solve this abysm with what it means to have a subjective experience, because I can have a sensor and the sensor is going to give an electrical signal, but this electrical signal of ones and zeros could represent whatever. It's just the programming that I have given that is going to use the signal in one way or another. But there is, again, this is the symbol grounding problem. And also, all this is stressing the concept that the body is nothing, which totally contradicts the Christian understanding of the body that explains that emotion, thought, and spirit are completely intertwined. And even we know that the most spiritual experiences that we human beings can achieve are very much related to the body. I brought this painting about motherhood as an illustration. I don't know if you're aware that Maslow, the same guy of the Maslow pyramid of needs, he was fascinated by transcendent experience. So he created a hierarchy of transcendent experience that goes from flow, which was very much in vogue a few years ago, to the most profound mystical experiences. And these experiences where one transcends his or herself, they mark, the qualities is that they mark the life forever. So once they happen, it's not that they will fade, they make us better people. So those are the two defining characteristics. And a third characteristic is that they come linked very often to processes that happen in our physicality, in our body. So for instance, with motherhood, we know that childbirth is the moment where oxytocin is the highest, and oxytocin is related to those type of self-transcendence feelings, in the same way that when a warrior is involved in a fight, there are also other neurotransmitters that are involved in these experiences. So to negate the dignity of the body is to negate spirituality as well. And now, just to finish, what does all this show us about what it means to be children of God? And the main thing is that we need to realize that traditionally we've had a very intellectualist interpretation of what Imago meant. And right now, we are seeing that with the intellectual idea, we are maybe losing what is most important. So it's not about being able to make some calculation, but about being able to understand it. Is the interiority what is what makes us different? We could talk about this will, about the possibility of having this will that was very much stressed by theologians such as Branner or Barth, more than this intellectual definition, or the interpretation of the interiority that was given by some others like Ricoeur. So this can help us see that what is important about us is not so much what we can do. It's not about doing more. It's not about the function, but it is about what we experience when we do that, about what we experience in this interiority and how our interiority relates to other interiorities and how it relates to God. And this is very much in contrast with the context where we live, where this dualism is also interacting with capitalism, so that everything in the end is related to numbers and is related to function. And what we discover here is that actually numbers and function might very well be the least important thing about what it means to be human. And it is true that if we use it well, of course, we will be able to assist in an unprecedented human flourishing, and let's hope that it is. If we have clear ideas, this will happen. If not, we will succumb to all the risks that will come in the way. And artificial intelligence can confuse us. And now we are living in a context of confusion, but hopefully it can also help us focus on what is important. So in conclusion, we are in this dualism and in this functionalism where essence and appearance are confused. We need to underline the dignity on the body, and we need to appreciate the authenticity of human experience. And this has very deep ethical implications, even implications towards what algorithms are ethically acceptable and what sort of algorithms are not, when we are making decisions that have real impacts on real people. And we need to establish goals and set boundaries to technology with these ambivalent potentials so that we can seize the potentials and avoid the threats. Thank you very much.
Thank you, Sarah. That was absolutely fascinating. Thank you so much. I'm sure there are going to be a lot of questions now. So I'll give, Roger's already got his hand up. I was going to say, I'll give people a moment. But Roger, you got in there first. So if you've got a question, go for it.
I pressed the wrong button. I was trying to applaud, not to ask a question.
Oh, no worries. So I'll give people a moment if they want to kind of write their questions or have a bit of a think about what they'd like to say. I suppose I've got a opening question really, and I think I can possibly work out what your response might be, but I'm going to ask it anyway. You said about the fact that the AI doesn't attach meaning to the symbols. It's just got. Do you think if we had potentially enough data about how we attach meaning, it would be the kind of thing it would be possible to convert in some format, or would it just mean we're layering one symbol on top of another without anything sort of qualitative in it?
Precisely. You will link one symbol to another symbol. So if I have the word for cat and dog and I have images, then I'm able to link the image to the dog. And maybe I can also link a video of a dog or the smell of a dog if I'm able to write it as numbers. I wouldn't know how to encode a smell, but I'm sure that it can be done. But what cannot be done is to encode it to the real experience of being with a dog.
Thank you. I thought that might be the case. Right, Andrew, Luca, then Paul, in terms of who's come up first. So Andrew, to you.
Okay, thank you. Yeah, thanks very much for that presentation. That was absolutely fascinating and a great tour and exposition of what is not there in AI, which is a subject having the experience. You mentioned a few times the contrast between the intellectual and the experiential, and also at the end you were bringing the Imago Dei. I just wonder, given that one of the historic interpretations of the Imago has been, rationality, and one of the big emphasis, from Greek philosophy on, has been the uniqueness of humankind as the rational animal. What do you think of the fact that to be truly rational, it's not just an intellectual thing? There's a moral pull to that as well, so that philosophers would be expecting that as a result of our rationality, we're able to choose the good. What do you think of that, and whether the numericalization of things can get to that point where we've captured what good is?
Yeah. So So basically, as you were saying, it's not about performing these functional operators that were only for humans and not for animals, and now AI can do as well, but it's about wisdom. So instead of about practical wisdom, about choosing the good and about experiencing beauty, it all has to do with some sort of an emotional component about the disgust that an evil deed generates, and inspiration that the good deeds generate. And there's been a lot of very interesting work already from decades ago, for instance, from Damasio, because for Damasio, rationality is something that uses not only that intellectual side, but also the emotional side. And it's through the emotional side that rationality actually can be implemented in the world as a decision. So I would truly support that.
Thank you.
Luca.
Yeah. So my question is actually, thank you very much. First of all, I really enjoyed the presentation. My question is very similar to Finley, in the sense that I've been reading that there are two kind of type of artificial intelligence. One is symbolic, where there is an attempt to represent the knowledge of what you of what the machine analyzed, let's say, and the other one, which has prevailed, is the artificial intelligence, which is called sub-symbolic, and is all the machine learning, deep learning, and they are different because the first one, the symbolic one, tried to actually reason, and it was a dream of Turing. That
not really.
And I don't know if you're familiar with
Yes. So if I
with
Newell
and Simon, which did the physical symbol system hypothesis, and the fact that the Searle experiment instead clearly show that the sub-symbolic AI is the one that doesn't understand what it's doing. So I think I can also send you some material, but I think the idea is that the artificial intelligence that has prevailed is the one that doesn't understand what it's analyzing because it's quicker. But it will be theoretically possible that the artificial intelligence understand more what they are doing against Searle.
Yeah, but yes, but no. So it is true that in my presentation, I was focused on sub-symbolic AI because it's the one that is dominating the panorama right now. I think that you can see my slides, and I'm sorry that this is in Spanish. This is from my lectures, and this is about symbolic AI. So basically, in symbolic AI, it's not that you are solving the problem of symbol grounding. It's just that you are using the symbol in itself. So let me explain. In the one that we are using now, for instance, with cat and dog and mammal and house, we are turning that into a chain of numbers. And those numbers, we perform operations with them. In here, what we have is a different symbol. So instead of having number 1, we have another symbol that is cat. Okay? And this symbol cat, we make operations directly with the symbol. But there is nothing that links that symbol to the reality of the cat. One way that we try to overcome this is what I have here, which is when we create, and this is already from the 80s, so we create these functional paradigms where what we do is that for each symbol, we try to detail the properties. So for instance, I will have the symbol cat, and then I would say that the cat is a mammal, that the cat is a pet. I will say many things. And the interesting thing about symbolic AI, and I think that your comment is very interesting because there are some things that are missing is in sub-symbolic AI that could be recovered with the symbolic one. And that one is that of reasoning. Because I said that AI does not reason, but that's not true. It can support reasoning in a quite good way, which is with this sort of systems. They are called expert systems. And what we do is that we are able to write some facts. And here I have some code, some example that I use for my students. But if we had half an hour, I could explain you how to do this. It's really, really simple. And the code is open source. As I said, this is from the 80s. So you write things such as a cat is a mammal. Mammals have a high body temperature. I don't know. You can write all the facts that you have and all the rules for reasoning, which can be usual rules, or maybe they can be fuzzy rules, which means that you are going to say more or less a cat, more or less a mammal, which for this doesn't really make sense, but you can say that someone is more or less smart or more or less a good person. And then you will derive all the possible consequences from that. And the machine is really, really good at that. And theorem provers work like this. And you know that theorem provers are right because they are exploring everything and they are using these rules for reasoning. They start from knowledge, as I have in the slide, and with the inference engine, you can get the results and you will be experimenting them. So yes, there is symbolic AI and symbolic AI. The most interesting part is this one that I'm telling you about, because it can perform reasoning tasks if we human beings tell them the rules and we give them the symbols. However, the symbols are still only symbols, and we need to be the ones giving them meaning.
Thank you, Sarah. I think that was really, really helpful as well. Hopefully that's kind of answered your question as well, Luca. Paul, you've got a question.
Yes. I don't know whether you've been familiar with the post office scandal that we've had in Britain over the last 10 years.
No.
But a very large number of sub-postmasters were prosecuted, some imprisoned, many bankrupted, because of a computer program used by the post office to do its finances. And the dogma was that the computer is always right. And the more the computer, or the more it was interpreted that the computer was saying that the post office, sub-postmasters they ran sort of little mini businesses for the post office, the more it said were corrupt, the more this fed on itself. So in a sense, it reinforced it, and didn't seem to dawn on anybody that why suddenly would a very, very large proportion of sub-postmasters, something like a quarter, suddenly be corrupt. I mean, it's the biggest scandal we've had for a very long time. Some committed suicide, some were imprisoned, many were bankrupted, and the establishment fought to defend this. Once it had that dogma, I mean, there are two things. One is it's that black box thing, isn't it? The computer is a black box, and the computer says this, so it must be so. The other is that I think that managers, you had the computer experts on one side in a different company, and you also had, it was Fujitsu, wasn't it, I think? And you had also managers. Now, often in Britain, senior politicians and managers have very little scientific or technological training. They very often are arts graduates. In the pandemic, there was nobody in the cabinet with a science degree. Well, there hasn't been anyone in cabinet with a science degree for a very long time. So they were simply taking what was said. So there are two problems there, I suppose. One is the black box, and the other is the people who you've been talking about. People need to understand. People in very senior positions who don't understand because they haven't had a technological scientific education. I think, because I did postdoc in Germany, and I think it's a far worse problem in Britain than it is in a lot of other places, where we tend to divide fairly early on into science and arts. And in a sense, the science is often seen as very specialized. It's actually the Frankenstein thing. You know, scientists need to be monitored because they will go over lines by people who are not scientists. Does that make sense?
Yes, and I really think that this point about science being something for specialists is I'm gonna borrow that for sure, because this is a key point. We talk in the chair. We talk a lot about scientificism which is a related aspect, because the science is only for those who are qualified, and then they can maybe make more decisions than what they should. But the opposite problem is also a very pressing issue. And this thing about the post office scandal, I wasn't aware, and I would research. There are so many scandals, like in Holland, there was another algorithm that was flagging the people who were committing fraud in getting childcare benefits. So all the people who they flagged as committing fraud, they asked them to pay back all the childcare benefits that they had received from 5 years prior. And there were so many people who ended up bankrupt because of this. And apparently the bias was for the people who had more than one passport. So if you had more than one passport, then you were flagged automatically as if you were a fraudster. So this is something that is a very, very pressing issue. So thank you so much for your comment, and this post office example, I will for sure dig out more.
Thank you.
Thanks.
Thank you very much, Aaron. It's absolutely fascinating. And if anyone's got any questions that come up following this, do let us know. Yeah, and we can forward them on to you. So if anyone does want to follow up with Sarah, yeah, do let us know, and we can forward those questions on.
Thank you so much. It's been a pleasure.
Thank you so much. On a virtual round of applause.